Greetings, future leaders of America. It's time to learn how to solve absolute value functions graphically. And when we say solving absolute value functions, we mean both equations and inequalities. Wow, exciting times. So, we are going to be using Desmos for this. So if you guys want to go ahead and open up a browser tab and go ahead and take a look at desmos.com/calculator, then you can kind of follow along. I'm also screen sharing, obviously. So I'll show you guys where I'm going and what we're doing. All right. So before we get into doing this, a couple of friendly reminders. Solutions are the points of intersection on a graph. Okay. It's where two things are intersecting because at that point of intersection, they are equivalent to each other. That's what makes them a solution. So in order to find the solutions, what we're going to do is we're going to graph each side of the equation and identify just the x value of their points of intersection. We don't really need the y value. We don't need to know like at what value they have equality. We need to know where they have equality. Okay. The only caveat to that is if you're solving an inequality, then we have to find a subset of the domain where the absolute value function is in the shaded region. Trust me, that sounds 10 times more complicated than it actually is. It's literally just, is it above the line or is it below the line? And that's about it. All right, so let's go take a look at a couple of examples. We're going to go through and graph these, but then we're going to verify those using, you guessed it, Desmos. So let's click on over to the first one here. So example one, we have the equation 2 equals the absolute value of x plus 3 minus 1. All right, so let's go and say we're going to make this one red and this one blue for no other reason than the red one came first instead of this. So if I'm going to go through and do this graphically, what I want to do is I want to draw a line where y equals 2. Okay, y equals 2 is a nice, easy horizontal line where it does not matter what x is, y is always 2. Okay, so y is 2 there, and it's going to stay 2 all the way across going to the right and all the way across going to the left. Is that a perfectly straight line? No. Maybe if I try and draw it this way, I can make it a little straighter. That's a little better. Still not perfect, but close enough. So this is the line y equals 2, okay? Because it does not matter what x is, y is always 2. But for our absolute value side, well, we got some creative graphing that we got to go through and do there. So let's remember that when we're graphing absolute value, we always need the vertex, what direction it's going to open, and we need to know the slope. So lucky for us, we can figure out all that stuff by pretty much just looking at it. So the vertex here is going to be the point -3, because remember, it's always the opposite, -1. So -3, -1. It's going to open up, and how do I know that? There's nothing that is in front of the absolute value, so it's got to be positive, so it opens up. And the slope is going to be just 1. Again, how do I know the slope is 1? Because there's kind of an invisible 1 that's just hanging out right there. So let's go ahead and graph this. So I'm going to go to the point where the vertex is -3, -1. So 1, 2, -3, and then -1 is down here. If the slope is 1, I go up 1, right 1. Then from there, up 1, right 1. Then from there, up 1, right 1. Then from there, up 1, right 1. And you can see I've got one point of intersection already. The other side is going to be up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. And again, you can see my multiple points of intersection. Okay, so playing my super fun game called Connect the Dots, I can go through this and I identify my two solutions as the 2 points of intersection. I've got one right here and I've got one right there. So where are those points? Those points are my solutions. So x is going to be equal to, fancy squiggly brackets because it's going to be a list. And where is this point right here? Well, this is -1, -2, -3, -4, -5, -6. So this point was -6, +2. And this point over here, well, that one was 0, 2. So the x values there are 6 and 0. Sorry, negative 6 and 0. So x is equal to negative 6 and 0. Okay? How could we go and confirm that using Desmos? Well, let me go and open Desmos. I'll make it a little bit smaller so I can kind of see what my functions are over here. So let's go ahead and type in the first one, which is just 2. But you notice if I type in 2, there's no graph there. So guess what you got to type in? Y equals 2. Then you get a nice pretty horizontal line. Okay. Then we're going to go down here and we're going to type in y equals, and then absolute value, you can just type ABS. Okay. Of x plus 3. Close those parentheses because that's kind of closing the absolute value, and then minus 1. So you can see here the graph that is on Desmos looks pretty similar to the graph that we did. Am I right? Of course I'm right. So looking at this graph, we can just kind of click and see that we've got points of intersection at negative 6 and 0. So we can also go through and verify this graphically. Okay. So warm and fuzzies, warm and fuzzies. All right. So let's take a look at the next example. So the next example, we have a little bit more complicated absolute value function. So we've got negative 2 times the absolute value of x minus 1 plus 5 is equal to negative 3. And just like the last one, we'll go through and we'll do the left side of it in red and the right side of it in blue. Okay, so let's go ahead and graph these things. So let's go ahead and graph negative 2 times the absolute value of x minus 1 plus 5. If I'm going to graph it, I need to know 3 things. I need to know the vertex, I need to know how it opens, and I need to know what the slope is. Okay, so the vertex is going to be located at the point positive 1, positive 5. So positive 1, positive 5. It's going to open down because of that negative. And the slope is going to be really plus or minus 2. I know we didn't do the plus or minus on the last one, but I'm hoping you guys just remember that it's always plus or minus. All right, so let's go ahead and graph this. So we're going to go to a vertex at 1, 5. So x is 1, boom. And then y is 5. So 1, 2, 3, 4, 5. Skadoosh. All right, so it's going to go down with a slope of 2. So I go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. Okay, down 2 to the right 1. All right, then on the opposite side, I go down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. Okay, could I keep going? Yeah. Is it necessary? Nah. So what I'm going to do here is I'm going to play my super fun game called Connect the Dots and make my absolute value graph. Okay, so we got the absolute value. That was the hard part. The easy part is graphing negative 3. So remember, I'm going to want to graph y equals negative 3. So in this case, it doesn't really matter what x is, so long as y is negative 1, negative 2, negative 3. So I'm going to go through and draw a nice horizontal line, and you can see right there and right there, I've already got some nice pretty points of intersection. Okay, so where exactly are they intersecting? Well, probably at that little guy and that little guy right there. So where is this point? Well, this point is negative 1, negative 2, negative 3, negative 1, negative 2, negative 3. So negative 3, negative 3. And then over on this side, we've got 1, 2, 3, 4, 5, and negative 3. So when I'm looking for my points of intersection, I would say that x would be negative 3 and positive 5. All right. Now again, let's go and check that on Desmos because Desmos is your friend. So we'll go ahead and just kind of adjust these as needed. So you can see, drag this over, and then maybe you can see. Nope, that didn't do what I wanted it to do. It's cool. We'll get it back. No worries. There we go. All right. So y is going to be equal to negative 3. So we'll just change it to negative 3. Okay. And then for the absolute value, we're going to say y equals, and then we're just going to type in negative 2 times the absolute value of x, but instead of plus 3, we're going to hit minus 1, and then we're going to change this one to a plus 5. Okay, and you'll see the graph that shows up on Desmos looks pretty similar to the one that we went through and did. Okay, so let's identify those points of intersection. So we'll just go through and say, well, that's where it's intersecting, and that's where it's intersecting. So did I get values of negative 3 and positive 5? I sure did. Negative 3 and positive 5 are right there. Okay. So instead of having to go through and isolate the absolute value bars and then split it up into the positive and negative equation to solve it algebraically, we can do it graphically. Okay. We're just finding points of intersection. Super duper easy. All right. So the last one we're going to go take a look at is what happens if it's a inequality. Dun dun dun. The short answer is nothing really changes. All right. So again, we'll kind of go through and say we'll do whatever's on the left side in red and whatever on the right side in blue, and we'll just kind of go piece by piece. So it doesn't even matter really at the beginning that this is an inequality. It's not really going to change what we're going to do until we get a little bit later. So I'll show you what I mean. On the left-hand side here, we have the absolute value equation. So what do I need to graph the absolute value equation? I need the vertex. I need to know how it opens, and I need to know what the slope is. So you'll notice inside the absolute value, it's just 2x. Like it's not 2x plus something or 2x minus something. So there's nothing else that's in there. So where is the vertex then? What's the value of h? Well, h has got to be 0 because there's nothing there. So it's going to be 0, negative 3. Okay, again, that's from h that there's nothing there. So 0 and k, which is negative 3. It's going to open up because I don't have a negative value at the front of this absolute value. And its slope, interestingly enough, is going to be, I think, 2. Okay. Now, you might be asking yourself, why would it be 2? There's like a 1 there. So shouldn't the slope be 1? Well, yeah, but there's a 2 right here. So maybe let's go through and do a t-chart just to make sure. Okay. Because we can go and we can do a t-chart just to make sure. So let's just assume that this was f of x equals the absolute value of 2x minus 3. Okay, so I know that the vertex is going to be located at 0, and that's going to give me an output of negative 3. So what if I plug in 1? Well, 2 times 1 is 2. The absolute value of 2 is 2. 2 minus 3 is negative 1. If I plug in 2, well, 2 times 2 is 4. The absolute value of 4 is 4, and 4 minus 3 is 1. And when I look at how this is changing point to point from negative 3 to negative 1, I add 2. From negative 1 to positive 1, I add 2. So there's a constant change of 2 every time. That means the slope is actually 2. We're not going to deal with too many problems where you've got a coefficient in front of the variable inside the absolute value, but I did want to give you guys one problem where you saw it just so you could see like, oh, well, in this case, it's going to be this sucker, okay? But worst comes to worst, you can always just make a little t-chart and it's super easy. So my vertex is at the point 0, negative 3. So 0, 1, 2, negative 3. It's got a slope of 2 and it opens up. So I go up 1, 2 and to the right, up 1, 2 and to the right 1, up 1, 2 and to the right 1, and do the same thing on the other side. You'll notice that this has what we call symmetry. We go up 2 and left 1, up 2 and left 1, up 2 and left 1. Oh my, look at that symmetry. It's almost like it's a mirror image, like it's almost a reflection over the y-axis. Amazing. Okay, so let's go ahead and draw those two perfectly straight lines to construct our absolute value graph. Right, but then we got to go graph 1. So we'll graph just y equals 1, right? So we go to 1, but this is just greater than, okay? So what I'm actually going to do is I'm going to graph it as a dashed line. Hopefully you guys remember that you use dashed lines when you're doing graphing and inequalities and it's just greater or just less than. But You probably haven't done any of that since you were in about seventh grade. So if you don't remember that, totally cool, not a big deal. All right. Because when we get to this part, we're again going to find those like points of intersection. But what is this question asking? When is the absolute value graph greater than the number one? So it's really asking, where is the red graph above, because that's greater than, the blue line? Well, it's above it from here and here. Okay, so you ready for this? It's going to get a little weird, but it's actually kind of cool. We go down to where that point of intersection is, and then we take it down to the x-axis. Okay, so where is that point on, and it's got to be on the x-axis. Okay, this over here is -2, and this one over here is +2. So you see how it's above it over on this side? That means everything to the left of -2, the red line is above the blue line. So that's going to be from -infinity up until -2. Over here on the right-hand side, well, it has a point of intersection at 2, and then the red line is always above the blue line. So it's going to be from +2 all the way over to the right to +infinity. And it's going to be these two things combined, so it's going to be union. Okay? So when is the value of this absolute value function greater than 1? Anytime you put a value for x that's in between -infinity and -2, or from 2 to +infinity. Okay? So we're going to see with some of the inequalities, remember how we said if it was like great or than, so it's, this part or this part? Well, that's why. And that's why when it's less than, it's in between this and this, because it's just this little v part down here. Okay? So hopefully seeing this graphically makes a little bit more sense. All right? I am going to try and show you guys how to do it on Desmos as well. So I'm going to go ahead and actually clear out the old ones, and we'll just start from scratch. So we'll type in the first function is the absolute value. So we just type ABS and then parentheses of 2x, okay, -3, and that's our little graph right there, okay? But I want to know where that is greater than 1. And looky there, okay? Desmos will actually give us the answer graphically, okay? Because where's this point right here? -2. Where's this point right here? +2. Okay, but let's put the graph on there as well, because I think it's really, it's kind of like powerful, as nerdy as that sounds, to go and see the graph and why it is that it works out being this way. So let's go through and do the absolute value of 2x, okay, -3. And then we're going to do this other one where we have to put y equals, because we're trying to make a horizontal line, 1. And you'll see those points of intersection. Okay, so everywhere to the left of this line, this horizontal, or sorry, this vertical line right here, you see the purple is above the black. And over here, everywhere in this green shaded region, the purple is again above the black. So it actually makes like perfect freaking total sense. Like, I love it. Okay. The other thing that you can go through and do is you could go and say, if you didn't have this one turned on, you could make this an inequality. And you could say, well, when is y greater than 1? Because it's a greater than, see? So every part where the purple is in kind of the black shaded is going to work. And where does that start happening? Well, from 2 and -2. All right? So, again, I think this right here is a really cool way to look at solving these kinds of problems and seeing why it is that you end up with kind of, the left side argument or the right side argument both being satisfactory solutions to that particular inequality. But if you're good with just kind of looking at the graph and seeing, that's totally okay, right? So to kind of recap what we've been through and worked on today, we talked about how to solve absolute value functions graphically. So remembering that solutions are just the points of intersection on a graph. So we need to graph and find the points of intersection. In order to do that, we need to graph usually like a horizontal line. We can also go through and graph the absolute value function. And then we're just going to find the points of intersection and identify the x coordinates of those points, and those represent our solutions. I realized that the two examples that we gave were all equal to constants. Could you do this if it was equal to like negative 3x or x minus 3? Absolutely. You just find those points of intersection. Okay, so graph it, find the point of intersection. The only thing that's changing when it's an inequality is we're looking for where one side is above or below the other side. And when we said it's got to be a subset of the domain, let's remember the domain is for absolute value functions, all real numbers. So it's everything from negative infinity to positive infinity, except for the bits that are in between -2 and +2, right? So you guys should be good to go for all of the questions that you have, your practice assignments. So let's make sure you work on them. And if you have any questions, please make sure to send me an email or pop by Wednesdays for office hours.